All right, so today we are jumping into similarity. So in the last unit we talked about congruent shapes, and remember when we're talking about congruent shapes, everything about them is the same. All of the angles are the same, all of the sides are the same. Now when we talk about similar shapes, we're no longer saying everything about them is the same. When we're talking about similar, they're the same shape, but they're not the same size. Okay, so in order for something to be similar, they're the same shape, but not the same size. So for example, we have that ABCD is similar to W, X, Y, Z. Okay, when we say the word similar, that shape, so ABCD is similar to W, X, Y, Z. Right, so when we talked about congruent, we had the equal sign with the squiggly on top. Now we just have the squiggly. Okay, so this is saying the two shapes are similar. Well, if you look, we still have the angles are equal. So we still have angle A is equal to angle W. We still have angle B is equal to angle X. Angle C is equal to angle Y, and angle D is equal to angle Z. So when we have similar shapes, angles are congruent, but sides are proportional. So what I mean by that is the sides are no longer going to be equal. When we talk about congruence, everything is the same. If this is 15, this is 15. If this is 12, this is 12. When we talk about proportional, we no longer have that they're equal, we have that they're proportions. So we're going to say that 15 is AB here, and AB matches with WX. And we're going to say that we're going to make a fraction. So that's going to be 15 over 5. We're going to say that that fraction is going to be equal to BC over XY. So that would be 12 over 4. That's going to be equal to DC over ZY, 21 over 7. Which is going to be equal to AD over WZ. Right, if I simplify this, I get 3, 3, 3, 3. So see how all four of these simplify to the same number. If these were different numbers, if this was 3, 3, 5, 3, then this shape would not be similar. We would not be able to say ABCD was similar to WXYZ. Okay, they have to be the same number when we make our fractions. So instead of saying AB equals WX, we say AB over WX equals BC over this. We need all four of these fractions to be equal. So for example, in example 1 here, it says use the similarity statement to list all the congruent angles and all the proportional sides. So we know because of our congruent statement here, F and J are in the same spot, first and first. So angle F is going to equal angle J. Angle G is going to equal angle K. Middle, middle. And then last, last. Angle H is going to equal angle L. And then we know that the sides are not equal, but that they're proportional. Now, when we write our proportions, the first one is always on the top, the second one is on the bottom. So we're going to have FGH be on the top and JKL be on the bottom. Okay, so FGH is on the top, JKL is on the bottom. So I'm going to say the first two, so FG is the first two letters. The first two letters here are JK. So FG goes with JK. The next two is GH, so GH goes with KL, and then FH goes with JL. Now, when we have the ratios of lengths of corresponding sides of two similar polygons, we call that the scale factor. Sometimes we hear that as the scale ratio. So whenever I'm giving you a thing, if we have two triangles and we know they're similar, I want to know what's the scale factor. So in that first example we did, the scale factor was 3, because when we divided all 4 of those sides, we got an answer of 3. Now when we're writing scale factor, we have to pay attention to the order. So if we have ABC is similar to XYZ, that tells us that ABC goes on the top, so that would be 6, and XYZ goes on the bottom. Now if I reverse it, if I say XYZ is similar to ABC, then XYZ goes on the top and ABC goes on the bottom. See the difference between 2 over 1 versus 1 over 2. So in this problem, we have PQR is similar to STU. So that means we have to put PQR on the top and STU on the bottom. So if I pick 8, 8 is going to match with 12. Now the reason I know that is because PR is the first and the last, and the first and the last here is SU. So that's 12. So 8 goes with 12. Then we know 6 goes with 9. Once again, 6 is RQ, and then TU is 9. Then lastly, we have 10 goes with 15. Now remember, PQR has to be on the top, STU is on the bottom. Now if I simplify these fractions, I don't want to see decimals here, we're going to simplify. 8 over 12, and we can press math, fraction, fraction, that gives us 2 over 3. Then 6 over 9, math, fraction, fraction, 2 over 3. 10 over 15, math, fraction, fraction, 2 over 3. So because all 3 of these are equal, that means our scale factor is 2 over 3. So in that problem, I gave you the picture and I wanted you to find the scale factor. In this problem, I'm giving you the scale factor and I want you to draw the picture. So we have A, B, C, D. So A, B, C, D. Now notice I went in a particular order. I started in the left and worked my way around. So now when I go to this one, I need to follow that same order. If I started in the left and went up, then I need to start in the left and go up. So R, S, T, U. Make sure you follow the right order. Now if we want it to have a scale factor of 3, that tells us that this one is going to be the bigger one and this one's going to be the smaller one. Okay, because we need this to have a scale factor of 3, meaning when I take this one divided by this one, I want it to be 3, which means the top one needs to be bigger. Now what we're going to do is we're going to pick a random number. So I'm just going to pick 15. Now if I want this to be a scale factor of 3, then that means that this one has to be smaller, but when I take 15 divided by something, it has to be 3. Well, isn't that the same thing as saying 15 divided by 3? So that's going to give us 5, right? 15 divided by 5 gives us 3. Now if I say that's 15, I can say this side is 15, which makes this side 5. Then I'm just going to pick a random number over here too. Let's say 9. So if this is 9, then this has to be 3. If this is 9, this has to be 3. Right? If I do 15 over 5, that gives me 3. Good. If I do 9 over 3, that gives me 3. Good.